online. The first one covering physical and online transactions, but the second one exclusive representing online orders. Applying several clustering algorithms to a set of selected variables, our main objective is identify and characterize distinct families, segments within each channel, enable a deeper understanding of their purchasing preference and behaviors. First, we start with the data collection, which is original data provided by Recheio from both Horeca channels and consists of transactions of products sold by the company during a period of 1 year. And each product belongs to a specific family that can be linked to individual customers. Data pre-processing is very important because we could have missing data, duplicate values, or outliers. Fortunately, here in this study, there are no new or repeated values, so we can pass directly from the variable selection to the outliers search. We are going to try 3 types of clustering algorithms: the k-means, the k-medoids, and the hierarchical one, which are algorithms to obtain a segmentation of the families in both channels. I think I'm going to pass this because most of you should know these clustering methods. So we start with variable selection in the total channel. Here, it is in cluster analysis, it is important not to use highly correlated redundant variables. So we are going to use Spearman correlation matrix between all pairs of variables to see which are correlated at most. And we use Spearman because the populations are not normal. And the selection variables should include most of the times selected of variables in enterprises are regulated for the characteristics of the cluster themselves. So we selected 2 types of variables for our study: the frac pair, which is the average amount of days between purchase in a given family. And we use another, the pencast pair, because this is the percentage of Recheio's customers who purchase a given family. There are 2 reasons for choosing these variables: because they are not strongly correlated and they are important to the company vision and business perspective. Initially, we make a descriptive analysis for the total Horeca channel, and we can see that we have only outliers in the second variable, the frac pair. The other one has no outliers. So in the second one, we use only resistant measures to characterize the sample, and in the first place, we use everything, every measures. Outliers are middle, and these families are actually very relevant to the Recheio, so it was decided to keep them. But on the other hand, due to low sales, less than 10,000 euros, company decided to remove approximately 30 families because they don't reach the sales thresholds, as these are insignificant for the business, and they decided to remove them. For example, we can say that we have a high variability because the coefficient of both coefficients of variation are high, and also, for example, here the median is about 5.5. It's the number of days between purchases of in mean terms of the families. We use the Helbo method as popular technique to find the optimal number of clusters, but we are we get too much important to the business objectives, because in practical scenarios, the number of clusters might be influenced by these objectives of the companies. And if the goal is to identify specific market segments for target market companies, a predetermined number of clusters could be chosen based on business needs. So we can see that using this Helmo plot, the elbow occurs at 3 clusters, and the inertia is decreasing more slowly above this number, but until the reduction in inertia becomes much less considerable for 6 clusters onwards. So we opted for these 6 clusters due to 2 reasons, because it enables internal comparison in Rusheio, which is similar cluster analysis for other branches of Geronimo Martins, which use the same variables. And the second one is it follows the business context of the company and is suitable for the subsequent comparison between Eureka channels. Well, we know what it means to evaluating the cluster performance. We analyze scatter plots, seed-weight plots, and seed-weight scores. The scatter plots show that well-separated and cohesive clusters with minimal overlap suggest a good clustering solution. And the silhouette plot is a graphical tool used to evaluate the quality of the clusters. And the width of the bars should be similar, and their weight should exceed the average silhouette score. And a high silhouette score indicates that data points are well clustered, while a low score suggests potential misclassification. So for the dotted channel, we have chosen the hierarchical with word linkage criteria because, as you can see, these clusters are cohesive and well separated. And for the silhouette plot, we can see that this measure ensures all clusters have several points with scores above the average line, and they have more homogeneous width, those taking have similar sizes. Moreover, this is the method that has the highest average silhouette score. We made the same type of descriptive analysis for the online Eureka channel, so I'm not going to say many things about this, only that in this case we have both variables with outliers, so we have resistant measures for characterize them. And after that, I'm sorry. Oh. After that, we choose the best method to characterize these clusters. This is the hierarchical with complete linkage criteria, and using the same criteria for the other channel, we can choose this method because it has also the highest average silhouette score. If you make a comparative analysis of the 2 channels after obtaining the segmentation for both, we rename the clusters to make more understandable in business context. So we from AF1 to AF6 instead of cluster 1 to 6. However, it should be noted that the composition of the clusters maintains. In table, we link the AFI groups with CJ clusters to simultaneously identify after the families belonging to each cluster and their respective variable values. AF1 represents the cluster with the most important families, while the AF6 is the opposite for the business. So we can conclude that for this graphic, there are a different kind of scale for the frequency, and the frequent pair is in this case indicates less frequency in the online channel, because we have the smallest number here, and we can see that fewer families with penetration above 5 50% in this case. Indeed, we can see in this graphic that the family in IF6 there is a great concentration of families, more than in the total channel, and we have some cases that lost a significant amount, like AF2, AF5, AF1, and AF4, that lost a significant amount of weight, and AF3 is likely to maintain the same number of elements in the two channels. And finally, we can note that here we have about 50% of the families. Only just an example. For example, in cluster 1, we have diverse range of products catering to various needs. And we have a high penetration, a moderate frequency, which suggests that these products are purchased sometimes with a high level of customer penetration in the total channel. And for the case of the online channel, for example, the cluster 1 contains fresh products and desserts. And these products are typically purchased with high degree of penetration and high degree of frequency, so suggesting high customer demand for these items in the online channel. To analyze the changes in customer behavior, we defined levels for both variables on each HoReCa channel, like this. We defined standardized levels to compare this behavior. And the quantitative levels from 1 to 5 correspond to qualitative levels from low to high. These classifications contribute to a meaningful comprehension of the penetration and frequency of customers' activities inside each channel. And it's important to say that the changes were deemed significant if families shift up more than 2 levels in any of the variables. This is 2 examples. I'm going to talk only about one. For example, the water family experienced a decrease in penetration, shifting from AF1 in total channel to AF2 in online channel, indicate a moderate decline in customer base and purchase frequency from the product category, because it changes in penetration. We pass from the level 5 to level 3 online, and from the frequency it passes from level 4, and it maintains on level 4. But in the first we pass two levels, so it's big exchanges. For conclusion, I would say that a clear separation of the company's products was achieved using various cluster analysis methods, and different groups were obtained based on the common characteristics of families, with the objective of better understanding the company's market. And finally, for example, for future research, I could mention the segmentation customer profiles and enriching the cluster ensemble. And this kind of initiative can further increase the effectiveness of research strategy, decision making, and optimize customer involvement. So thank you for your attention.
Thank you.
I'll have to leave some acknowledgements and references. Thank you.
Thank you once again. Some questions, some remarks. We have 1 minute for this. I have one remarks. We are statistical. We say statistical significance, and sometimes said the choose of number of clusters are the criteria. The principal criteria is the company requirements. Why?
Because they say to us that it's very important to make comparisons, and because the inertia is slowing down, so I think it was not so bad. The elbow is on indicator, is not, it indicates 3, but above 6, they stay stable, more stable. So we don't think it was a bad thing. And for them, it's very important because they have another kind of comparisons they made inside the enterprise. So it was a compromise between the two things, you know.
Okay.
It's not very good in terms of statistics, but it's not so bad. So we have to, yes, because when we operate, this is an internship of the student in the enterprises from 6 months. And in enterprises, everything is different, as you know.
Yes.
So we have to balance the two things.
Thank you, Sandra.
Thank you.
Some more questions? We proceed with the PowerPoint presentations. The next two presentations are for my students. I'm the responsible for these presentations. The students, it's impossible to be here, so they record their presentations. If you have some questions, I can answer to them, right? So this is the, no, this is the slide. Yes, the page. So this is the second presentation of the categorical principal component analysis.
Good morning, my name is Andrea Gomes, and I will begin my presentation with the topic ICCSA in R, application to sensorial data of wine testing. In science, researchers are often faced with a large number of variables they wish to reduce, while minimizing the information loss. Categorical principal component analysis, commonly referred to as ICCSA, emerged as an alternative to the traditional principal component analysis, PCA. CAP-PCA allows for the reduction of data dimensionality to a smaller set of new uncorrelated variables called principal components, preserving as much variability as possible. However, this analysis is only valid for continuous variables with numerical scales, assuming linear relationships between them. Therefore, it's not an appropriate method for categorical variables, which are the focus of this work. CAP-PCA, also known as nonlinear component analysis, aims for the same objectives but allows for the analysis of variables measured on different scales that might not be linearly related. It assumes optimal scaling to assign numerical quantification to the categories of each variable, ensuring that the maximum variance is accounted for. These values are called category quantifications. Thus, the main motivation of this work was to investigate the tools available in the R software for CAP-PCA and apply them to a real dataset of wine tasting evaluations. The quantification obtained through optimal scaling is based on minimizing the loss function of alternating least squares. CAP-PCA allows variables to be classified according to the level of nominal analysis, where neither orders nor distances between categories are considered, the level of ordinal analysis, where the order of the categories is taken into account, and the level of numerical analysis, where both the order and equal distances between categories are considered. The spline analysis level differs from the others as it uses polynomial functions. The literature suggests using splines when the number of categories exceeds 10 or surpasses the number of samples. Regarding the measures for integrating this analysis, the variance explained for VAF is highlighted. It is equivalent to the sum of the eigenvalues, which represents the amount of variance explained by each principal component. Content loadings are a measure that quantifies the influence of the transformed variables in the creation of the principal components, with values ranging from -1 to 1. Convex alpha measures the internal consistency of the model. The higher the value, closer to 1, the greater the reliability of the model and each dimension. And finally, the number of principal components directly influences the results. They can be determined through the script plot or by the eigenvalue, where components with an eigenvalue greater than 1 are chosen. R language is widely used in data science due to the numerous packages it offers, containing functions and algorithms for various types of processing. A literature review associated with the exploration of VR software identified the DP and the almost package with their functions, wrinkles, and almost as the only tools currently available to directly execute CAPTCA. The DP package descends from the almost package as a more user-friendly and flexible version due to a difference in the formulation of its loss function and the use of these lines. Therefore, the Pringles function from the DP package was chosen as the best package. To further explore the DP package, a set of sensory data collected from tasting of 7 different wines categorized from A to G was used, where the parameters are qualitative sensory descriptors determined by a panel of 6 tasters. Following the processing and elimination of non-essential variables, the dataset comprises 126 observations and 25 variables, with 5 of those variables having missing values. The variables are categorized into olfactory assessment, gustatory assessment, and appearance groups. For the variables wine and taster, a nominal level of analysis was chosen, since they correspond to the type of wine evaluated and the respective taster, and therefore the order is irrelevant. The same analysis will apply to the variables clarity, color, intensity, and evolution. The nominal variables were automatically encoded into dummy variables by the Pringles function. For instance, the variable wine initially had 7 categories, A to G, was transformed into 6 dummy variables labeled wine.1, wine.2, and so on till variable wine.6. The same approach was applied to the remaining nominal variables. For the remaining variables that have an ordinal qualitative measure scale, an ordinal level of analysis was conducted. For this analysis, the first 7 principal components were considered, based on the split plot shown. Additionally, for the Pringles function, the argument copies was set equal to the number of components for the nominal variables, to ease linear restriction on this type of variable. Regarding the missing values, an option A was chosen within the missing argument of the Pringles function. The initial 7 components collectively explain 66.64% of the variance of the original variables, with the top 2 components contributing to the highest percentage of VAF, with a cumulative VAF value of 31.19%. So the subsequent plots will only illustrate the first and the second dimensions. Therefore, the results will be based on the first 2 components. To illustrate the impact of choosing a specific quantification level for variables, transformation plots were applied. For example purpose, in this presentation, only the plots for the variables wine and taster are represented. The x-axis represents the original values and the y-axis the corresponding transformed optimal values, making it possible to see the shape of the transformation obtained. The black lines depict the transformation in the first dimension and the red lines in the second dimension. Due to the rank -1 restriction, only the transformations from the first dimension are significant. The complete loadings obtained are also displayed in the slide. Values highlighted exceed 0.5 and are thus considered significant for the analysis. As mentioned earlier, for the nominal variables, the loadings are obtained through dummy variables, and that's why they are represented with a dot and a number. Considering the values of the content loading together with the joint plot, which represents in a single plot the content loadings of the ordinal variables and the quantification of the categories of the nominal variables, it is possible to establish the most important relationship between variables of the first 2 components. Analyzing the graphs geometrically, we can see that variables structure, persistence, balance, acidity, and citrus fruit contribute more to the first component as they form an angle smaller than 45 degrees with the axis representing it. The variables floral, deep, mineral, and free fruit also make the condition. However, their contribution is much smaller since the vectors are shorter and closer to the origin. The second component is more influenced by the variables sweetness, dry fruit, and carbon dioxide, which have positive values on the second components, and by the variables honey, dried vegetable, color quality, and fresh vegetable with negative values. The variable tropical fruit also has an angle called the 45 degrees with the y-axis, but does not significantly influence its formation. The variable sweetness displays an angle closer to 45 degrees with both axes and thus has a smaller influence on both components. The variable astringency shows the same characteristic, but its influence is minimal. Regarding the points of the categories of the nominal variables, their position reflects the relationship with the ordinal variables. According to the obtained discrimination matrices, it was concluded that the variables intensity and color are discriminants in the first component, the variable clarity discriminates on the second component, and the variable evolution does not significantly influence either component. The categories A, C, D, E, and G of the variable wine are mostly clustered at the origin of the plot and are not associated with any components. The wines B and F are similarly related to the variables bitterness, dry fruit, and carbon dioxide and sweetness. Also, the tasters can be grouped according to the characteristics they evaluated. As the variables they are close to on the graph significantly influence their evaluations. Tasters 1 and 3 are associated with the first component, tasters 2 and 5 with the second component. Tasters 4 and 6 are close to each other, indicating similar evaluations but are located near the origin of the graph, which not allow for significant conclusions. Based on this interpretation, the first component can be defined as wine quality, as those variables contributing to this formation describe fresh characteristics with a persistent and balanced flavor, where the intensity of the color has a significant influence. The second component is moderately influenced by wines with olfactory characteristics of fruits, dry vegetables, and carbon dioxide, and a sweet taste, and strongly influenced by the aroma of fresh vegetables and the bitter taste. So this component can be defined as wine aroma. The object scores plot reveals three distinct groups, highlighted here with circles. Objects within the same group share similar scores on the components, indicating that this division is related to taster's assessment patterns. The group on the right consists mostly of evaluations made by the taster 3, where the choice of the strong category dominates for the intensity variable. Meanwhile, the group on the third quadrant is mostly evaluated by the taster 5 and includes evaluations where only the crystalline category for the clarity variable was chosen. The larger group brings together the remaining tasters 1, 2, 4, and 6, being abstract regarding the selection of categories and the influence of the evaluated variables, as it encompasses numerous observations in just one group. Additionally, it is also possible to relate the object scores to the component loadings through the bit plot. This plot reinforces the previously explained observations. To enable the users to perform CAD-PCA without writing a single line of code, a web application in RShiny was developed. Named Giphy, this application provides a more intuitive and simplified way for users to visualize the Pringles function from the Giphy package. It was created to allow users to upload their datasets to the web page, define the analysis parameters, and execute the CAD-PCA and review the results, all processed through selection buttons and input spaces. A user guide is provided in the application containing information about the functioning of the entire application. In the upload file section, the user is prompted to upload the data file. The Run Analysis tab allows the user to set the analysis parameters. The parameters on the left column are fixed, while the parameters on the right column only appear after uploading the data file. In this case, the first question allows the user to choose what type of analysis they want to perform, similar to what happened in the original function. If the user chooses the predefined levels option, as in the example, they choose for each variable choose the analysis level, spline degree, the number of copies, and whether the variable is considered active or not. There is also a possibility to configure a spline analysis manually, choosing the manual splines option. For that option, only the questions regarding the selection of the analysis type is replaced by questions for specifying whether the variable in question follows an order, the type of internal nodes, and the number of nodes for that variable. The remaining questions regarding the spline degree, number of copies, and if the variable is active persist unchanged. In the summary step, summaries of the obtained results can be assessed. At the value step, it is possible to check all the values obtained through the Pringles function. Additionally, users can utilize the application for accessing and downloading graphical results, such as the spree plot, the transformation plot, the loading plot, the journey plot, the object plot, and the B plot generated from the analysis. In summary, considering the initial objectives, the GIFI and the almost package stand out as the only R tools with functions to apply CAD-PCA. Throughout the study of this package, GIFI was chosen as the most flexible and comprehensive option. To further explore the functionalities of the GIFI package, an analysis of wine tasting dataset was performed, which provided valuable insights into the dependency structure of the wine data, which holds promise for future research within the wine industry. Based on the Pringles function from this package, a web application in RShiny was developed to facilitate the execution of CAD-PCA without requiring code. In the future, it would be interesting to consider including other softwares for executing CAD-PCA, as well as testing additional functionalities that were not covered in this work. It is also of great interest to improve the application dynamic and keep it updated given its utility in various fields. Thank you all for your attention.
Thank you for your invitation. And I agree. If you have some questions, some remarks, I can answer them. Nope. So let's see the second movie. The second one, the second speaker. This is one. About statistics about the wine, I don't know. This work was a work joint with the Department of Psychiatry of Hospital Braga, and this is a predictive application for early delirium detection. Subtypes.
Today I will present my article, Predictive Application for Early Delirium Detection Subtypes using GLMs. First, we will focus on framing the topic and the methodology used. We will also discuss the results related to the selection of the best predictive model, and finally the conclusions. Data science aims to approach and analyze the research of data. This field encompasses the study of the generalized extraction of knowledge from data. It aims to detect patterns to accumulate meaningful knowledge when applied to medical research. In recent decades, pharmaceutical and technological advancements have culminated in an increase in average life expectancy. Conversely, population aging has triggered a higher incidence of cognitive deterioration. Delirium is an acute neuropsychiatric dysfunction, prevalent in patients admitted to hospital settings of inpatient and intensive care, and is clinically characterized by agitation, deafness, and clouding of consciousness, associated with behavioral and cognitive disturbances. Being a multifactorial manifestation that develops over a short period, it is often underdiagnosed and neglected. Delirium is a result of interaction between predisposing factors present before hospital admission and precipitating factors that overlap during hospitalization, resulting in different subtypes based on the motor activity profile. Individuals exhibiting the hyperactive subtype present a state of hyperarousal, often characterized by hypervigilance, hallucination, and aggression. On the other hand, the hyperactive person presents a decrease in alertness, lethargy, and apathy. In turn, mixed delirium is the alternation between hyperactive and hypoactive states within a single episode. Therefore, there is an urgent need for an effective tool to predict the occurrence of delirium and its subtypes to minimize the harmful consequences of this disease. In order to achieve a more accurate diagnosis, the aim is to determine which risk factors most often contribute to the development of each subtype and finally to develop an application based on the methodology of generalized linear models, specifically multinomial logistic regression, to assist health professionals in the diagnosis of delirium. Multinomial logistic regression estimates the probability of occurrence of the different possible results of the response variable, which has at least three unordered categories: qualitative, nominal, and multi-categorical. The estimation is based on a set of ordinal, continuous, and categorical explanatory variables, which shows that any package which implements the multinomial logistic regression model based on artificial neural networks to model the relationship between the independence variables and the response variable. Additionally, it stands out from the others because it deals with categorical and numerical variables simultaneously and also automatically codes categorical variables into dummies, which are binary variables created to represent a variable with two or more categories. The database collected at the private hospital includes information on 124 individuals admitted to the emergency department and 112 variables. The age range of the study population varies between 18 and 100 years. The outcome variable is multinomial and refers to the diagnosis of the living, being determined using the RASS scale that assesses the state of sedation or agitation that the individual shows considering only visual contact and not of psychic state. The response variable has three possible categories: absent, representing 0, the hyperactive subtype as 1, and the hyperactive subtype as 2. Although there are names for other subtypes of disorder, only these two were considered when collecting the data. Furthermore, the database has numerical data regarding age, sears, and RASS criteria, period of hospitalization, and blood results. Information regarding gender, medication administered, and alcohol dependencies is binary. Finally, the categorical variables concern the patient origin, admission categories, and diagnostic group. The pipeline is outlined with the main steps and the respective results for implementing the classifier. Initially, we have pre-processing. The next phase is the division into the test and training set, followed by balancing the training data, implementing the model, and adjusting the hyperparameters to obtain the model with the best predicted performance for diagnosing delirium. Data preprocessing is crucial to predictive model implementation, involving a variety of methods to improve model performance, avoid overfitting, and reduce data complexity. Cleaning raw data identifies incorrect missing values, outliers, and erroneous values. Through the immediate package, a higher number was perfectly verified. Dimensionally, reduction techniques were then applied to categorize medication according to pharmacological groups, and that the information includes a normalization of numerical data by the min-max scale and the coding of categorical data, and this step is not applied when using the MNet package, as it does so automatically. Thus, the resulting database contains 29 eventful variables. The database consists of 342 patients without delirium, 74 with the hyperactive subtype, and 18 with the hyperactive subtype. Considering the unbalanced nature of the dataset, in which there is a significant disparity of samples between the different classes of the response variable, the stratified division is the most appropriate as it preserves the proportion of classes in the training and testing set. Data imbalance causes problems for predictive models as they tend to favor the majority class. Therefore, to balance the training set, oversampling techniques are the most appropriate in this context of limited data, as they generate synthetic samples from the minority class, hypoactive and hyperactive subtypes. To design the techniques were considered the smooth algorithm through the interpolation of characteristics between existing samples, selects an example from the minority class, and identify the key nearest neighbors, generating synthetic examples based on the similarities between them. In contrast, Edison considers the density of samples around instances of the minority class. In other words, it is adapted to the data density and produces more synthetic samples for instances of the minority class located in less dense regions. The database was initially divided using stratified division, allocating 7% of the data to training and 30% to testing. Next, we proceed to implement the training data balancing strategies, which cannot be applied to the test data because there cannot be a coexistence of information between the two sets. Through graphs, we can see that both methods guarantee a more equitable representation of the different categories. The results obtained to the unbalanced data and the balancing techniques using multinomial logistic regression were compared, which had the absence of delirium as a reference category. Regarding imbalance, the AUCPR metric depends on the distribution of categories and places greater emphasis on the performed on the minority class, displaying significantly low values in line with speculation. The model is enabled to correctly identify examples of the minority class, generating many false negatives, resulting in low sensitivity values for the subtypes. A higher F1 value indicates a balance between accuracy and sensitivity, ensuring accurate identification of positive instances, minimizing false positives. A higher IUCPR demonstrates the model ability to achieve higher precision and sensitivity. When AUC ROC values are higher for all classes, it means that the model effectively discriminates and distinguishes between the various categories. The result of this study demonstrates that Edison is a highly effective technique for improving model performance on imbalanced datasets as it obtains superior values for the F1 accuracy, AUC ROC, and AUCPR metrics. Metric values are low because synthetic samples were generated based on existing ones, which did not increase variability. Variable selection aims to determine the smallest subset of the most relevant and informative variables, which result in superior performance and better generalization capacity. Wrapper methods are implemented during training and include sequential search, such as for techniques that start the variable and iteratively incorporate only if it results in improvement in performance. Backward includes all variables and iteratively eliminates one. Bidirectional combines both techniques. Recursive elimination removes the least contributing variables iteratively. Embedded methods implement regularization techniques. Predictors whose coefficients are equal to 0 are eliminated. The GLMNet package is used to implement models with regularization, allowing the adjustment of penalty values, lambda. Alpha controls the type of penalty. Lasso regularization, what means alpha equals to 1, ridge regularization, alpha equal to 0, and elastic regularization, alpha between 0 and 1, being the combination of the previous two. To compare the various models, a reference model without any selection is required. The test set being balanced with 18 observations for the hypoactive class and 8 for the hyperactive. The AUC ROC metric is the one that should be taken into greater consideration as it discriminates between the different classes. The wrapper methods were implemented with the MNet package, so the same independent variables are used for all categories of the response variable. The former method does not show any improvement compared to the reference method, such as the recursive elimination, despite having reduced the number of predictors. Whereas the backward and bidirectional methods reduce the number of attributes and obtain a slight improvement in predictive capacity, being more noticeable in the backward method. On the other hand, the embedded methods implemented with the GLMNet package identify only some dummy variables as relevant for certain categories. Alpha values close to 0 result in a more generalizable model with more attributes, 36, while values closer to 1 make the selection more rigorous, obtaining 12 predictors. The estimates are similar to the referencing. Finally, in models 7 to 10, elastic regularization was implemented for different alpha values, where the model with alpha equals to 0.1 shows better results with higher values for the AUC ROC metric and a slight increase for AUCPR and F1. Although models 8, 10, and 11 show similar results with a smaller set of variables, model 7 was chosen as it placed greater emphasis on the higher value obtained by the metrics. Comparing models 2, 3, and 7, which reflect similar performances, the one with the greatest reduction in dimensionally and different predicted variables for each category was selected, corresponding to model 7. The negligible values for the ACPR, especially for the hyperactive subtype, reflect the model difficulty in classifying the subtypes in the test data, revealing it to be insensitive, being more specific because to capture more information regarding the absence of the link. This is due to the low representation of classes in the data, with only 6.50% corresponding to the hyperactive subtype. The selected model excluded only 2 predictors as they were not significant, which correspond to carbon dioxide pressure and the pharmacological group of antihypertensives. The hyperparameters tool makes it possible for cross-validation to select the best set of parameters that return a model that demonstrate the best performance. This process compares all lambda combinations, trains a classifier, and finally assigns an evaluation metric. In general, the tuning results show higher values, which translates into superior predictive capacity of the model. The graph was constructed based on the values of the coefficients of the 27 variables. Those with positive coefficient reveal that the creditor contributes to the currency of the hyperactive subtype, while negative values indicate that the variable predicts absence. For the hyperactive, the most contributory factors are the period of hospitalization, alcoholism, analgesics, and cardiotonics. The conversion into odds ratio allows to describe the influence of factor on the dependence variable. Quantify an impact of interaction. Regarding analgesics, individuals who consume them are 2.018 times more likely to exhibit hyperactive bulimia. On the other hand, for male individuals, the probability decreased by 0.512 times, that is, the reference class absence, is more likely. Similarly, the most influential factors for hyperactive bulimia are PCR, age, and pressure of oxygen. An increase of 1 minute in PCR increases the probability of this subtype occurrence in 14.856 times. A web application was built using the Shiny package to facilitate the use of Model 7 to estimate the diagnosis of bulimia. The application has 5 sections that concern the home page and information about estimates are performed by filling in the fields requested in the application form, which refer to the 26 independent variables previously selected, with variables relating to drugs allowing you to select more than one attribute. The application displays predefined values that are required modification, so each variable is restricted to a range of values similar to those present in the training data. It has a section dedicated to confirming the data filled in with a button to generate the prediction. Finally, there are 3 possible outcomes for diagnosing according to the categories of the dependent variable, which is presented in the prediction section. It's concluded that pre-processing is crucial for modeling, having reduced the initial database from 112 to 28 independent variables. Although Anderson was the best technique to resolve the class imbalance, it is possible that it introduces more inconsistency in the new records. The elastic variable selection technique with an alpha of 0.1 obtained the best performance, having exposed the pressure of carbon dioxide and antihypertensive variables. For the hyperactive subtype, the period of hospitalization, alcoholism, and analgesics are the most contributory. For the hyperactive subtype, PCR, age, and pressure of oxygen are the most relevant. The application was built with 26 independent variables, which, through an intuitive interface, aims to assist healthcare professionals in diagnosing bulimia in the emergency department. From a future work perspective, other machine learning algorithms can be implemented in a multi-categorical and nuanced context, such as random forest and other variable selection methods. But the most essential thing is to collect more records for the subtypes, and it would also be advantageous to incorporate them all into the hospital system to automate the process. If you have any questions, reach me out through this email, and thank you for your attention.
So if you have questions, I can answer them. Any questions, any remarks? No? Yes?
I have a remark. I think that the area under the car is too low.
It's
It's really too low,
Yes.
because when you have 50%,
We can distinguish,
Yes,
we
so-
can discriminate, but in this case, I know this metric is very, very low. It's not agreeable to me to work with this. But we think the unbalanced data produce better results, but we need more results in hypo and hyperactive subjects, because they can train better the model. We don't use the whole information of the data, we use 70%. I suppose if we collect more data, this is the first approximation. It is true, it's not satisfactory, but the F1 score works.
and the second thing is that sometimes medical psychology decide by themselves how to group data. and I worked with this kind of data. And when I worked with this kind of data, we selected data on the basis of clusters, because you cannot decide by yourself on the basis of your experience if you are of the group 1, 2, or of course if you have not signed on, you are in the first
The
group.
classification are made by physicians, psychiatrists.
Yeah.
And this is in the context of urgency. When the patient is admitted, they have the score of RAS and the other SIRS, and they collect the mood data. Sometimes it's difficult to see if the patient is alert, is classified in hypo or hyperactive.
Yeah.
It's difficult, very difficult for the psychiatrist.
Sometimes they have some, they perform some tests, and on the basis of the result of these tests, they apply to a category instead.
Yes, they do the scale, the RAS scale.
Yes, something like this. I don't
Something
remember
like
exactly
that,
the name.
yeah.
Okay.
And they classify according to this. Thank you.
Oh, you're welcome.
So the other speaker, Sandra, again. Very repeated.
Yes, yes, yes.
The next speaker is again Sandra with another work entitled Regression Models in Lubricant Oil Quality Assessment. When you are ready, you can start with 15 minutes.
So this is a joint work with Ricardo Guissa, a colleague of mine of mathematics, the Francisco Cedas, a student, and Paulo Ferreira André Silva from the Galp company.
It doesn't work. Try to put on.
Okay. Oh, thank you. Thank you so much. Okay, so first I'm going to make a quick introduction. Quality and Technical Product Care Department of Galp intends to carry out predictive maintenance of industrial equipment. And they do that throughout data analysis and the corresponding assembly of a model to support decision making when they want to monitorizing the lubricants in service. They evaluate the remaining useful life of a lubricant. It is important to prevent damage in the equipment and is essential to provide the customer with a forecast of the condition of the lubricant, so in the way that the damage does not occur. This can be accomplished by data modeling of the lubricants in service. Let's talk about the data set. The dimensional department of Galp deals with quality technical assistance and services associated to solve products, whether fuels, chemicals, or lubricants. And this study focuses on monitoring lubricants with the principal aim to make a decision regarding the time interval in which the oil renewal should occur throughout the analysis of laboratory data. Data samples were collected from the equipment, and then they were sent to the laboratory, being classified according to the record values in each of the physiochemical tests. So we have three types of explanatory variables. They result from laboratory analysis and carry out on lubrificant samples. The first ones are related with physical-chemical state. The second ones result from the wear of a metal, and the last ones linked to another type of contamination. For example, the physicochemical composition of the lubrificant variables, they are obtained throughout the useful life of the oil, and these values are compared with the initial condition of this oil. For example, we can say that salt, the sulfatation, is in a chemical reaction of the lubricant with sulfur and results in acid compounds. In the second ones, for example, the Al, the concentration of aluminium in the lubricant oil, is a variable that reflects the oil contamination due to the wear. And the last ones, the variables concerning external contamination, we can talk about, for example, the Na, the sodium content, that frequently originates from the refrigerant. An important variable is the responsible or dependent variable, which we designate by H oil, is the number of hours that the lubricant oil is at service. The lubricant oil in service is only removed and consequently completely renewed when, after a sample analysis, it is diagnosed as being dangerous. This means that observations correspond to the same oil load follow an increased function in the variable H oil, which is only interrupted when the next observation corresponds to another load. We also consider a categorical variable resulting from laboratory analysis, which is the diagnosis category represented by Ci for the observation I, which can have three possible states: the normal, the watch, and the risk. This variable will later be associated with the number of hours of service of a given load, and this association is the one that reduces most wrong diagnosis. Data sets on which we base our model comes from the biogas motor generators that involve 172 observations analyzed about 3 years. Since new oil charges are always stocked up and when considered obsolete are fully removed, the majority of special observations belong to the same lubricant charge. And this can be a problem. We are going to apply two modeling approaches. The first one is the multilinear regression model, using the entire amount of a sample, but we have a problem because this is not the most appropriate, because observations belong to the same oil loads are independent. So the coefficients for this regression were estimated using a cross-validation technique to mitigate the effects of this dependence. The other approach is the linear regression model with mixed effects. We have grouping the dependent oil loads and remove loads with few observations. Speaking about the first model, we analyze the correlation between all variables using Pearson correlation coefficients and sample correlation values between each pair of variables and the corresponding p-values associated with the significance tests of the population coefficient were represented in this matrix, we can identify the significant I sample correlation coefficient, and these significant correlation coefficient correspond to p-values less than 5%, leading to the rejection of the null hypothesis. And for each pair of variables under these conditions, the one with the lower correlation coefficient value with the response variable is removed. So after this process, we stay with 5 explanatory variables that are here described, and we adjust the multiple linear regression model following 2 different procedures. First, with variable selection made through the post-test for each model coefficients, and second, by stepwise variable selection algorithm. The first procedure, in first place, we saw that the regression model is globally significant because the p-value of the f-test is practically null. And after that, which we choose to exclude the variables whose p-value relative to the significance test of the respective coefficient is higher than 55%. The second procedure is the stepwise method with both forward-backward algorithm and variables that better explain the response variable are selected among the 5 remaining ones, optimizing the number of variables. But for both procedure, the explanatory were the variables were the same and were sulfatation, silicon content, and viscosity at 100% degrees. The cross-validation to estimate the coefficients was obtained with 5 multiple regressions with 4 or 5 groups. Final coefficients were obtained from the average of the 5 coefficient regressions, and the estimated equation model is given by this equation, and each coefficient represents the change in the number of file servers per unit of the corresponding independent variable, keeping the values of the other independent variables constants. We should validate the regression model adjusting this seeing that the residuals must match 3 assumptions: independence, homoscedasticity, and normality. And we go to first made a graphic analysis of the residuals. So, I'm sorry, I don't know what happens. Okay. First, concerning the dependence, we can see that not all the points here in the parallelogram are inside the blue band, so these are outside, and this can mean that can be an indicator that the correlation that there is correlation between residuals, and this can be confirmed by the Darwin-Watson test when we obtain a value of 1.04, which is below 1.5. So the null hypothesis is rejected, and therefore there is a positive autocorrelation between the residuals. In what concerns homoscedasticity assumption, we can see that in this scatter plot, we can see that the variance seems to be constant because the points are dispersed randomly without presence of any pattern, and this can be confirmed by the Brush-Pagan homoscedasticity test, which has a value of 0.65, so it's higher than the significance of 5%, so we can say that the variance of the residuals appears to be constant. And finally, the normality, we can observe these two graphics. The first one, the histogram with the polygon and the Kiki plot, we can see the points are nearest the line. So we can assume that we can see that maybe they are normal. But when we made the Shapiro-Wilk test, we see that at 5%, this hypothesis is rejected, but we note that if we consider 1% normality, we will already be verified. So we have, this is not very good. We have to be careful. Okay. So we have not the 3 assumptions verified. So we decided to see if the adjustment we have the adjustment very good. However, it's not the most suitable model for this data set because the independence of the observations is not verified. So we are going to try the multilinear regression model with mixed effects. After considering groups of observations, take into account lubrificant oil to which they belong, as well as the removal of groups with the total observations smaller than 3. The final data consists of 144 observations split into 26 groups. These mixed effects can include random intercepts or random slopes or both. So we will see which is more appropriated. We start with an analogous procedure to make the variable selection, and then correlate variables work exactly the same to the other model, but when using the variable selection methods, instead of 3 variables, we stay with only 2 variables, the sulfatation and silicon content. To understand whether it makes sense to introduce random interceptions, we analyze the box plot of the response variable, and due to the evidence difference in the number of observers between groups, comparing the medians of all these box plots, it makes sense to insert random interception in this group, meaning that the mixed model will have different random interceptions, and for the I group we have this equation. 2 minutes. 2 minutes. Oh, está mal. To investigate the possibility of introducing random slopes, we analyze the graphs containing the simple linear regression between a predictor and the output variable, and we can see for the silicon content in the left that the regressions present similar slopes, so we don't need to apply a random element to the coefficient of this variable. On the other, on the right, for sulfatation, we have quite different, some regressions quite different from the majority, but in general most regressions are similar, so we consider that the complexity that we will introduce, it's not justifiable, so we don't introduce random slopes. The model is this one, and we have an example, but I have not much time. So, for example, for the first group, the value of the intercept value is this one, and we have this equation. I don't speak too much about these things. The analysis is the same. I will only say that for these mixed models, the 3 assumptions were verified, and when we compare the 2 models, indeed the mixed model is much better because it has less one variable, have similar R square adjusted, and the AEC is much smaller, and it verifies the three assumptions, so it's much better. And finally, if I have more 1 minute, oh, okay, we can find an optimal confidence interval, which is possible to infer the total service hours when we renew the lubricant, avoiding the performance of ester testing. And our main goal is to provide an estimate for how long should the load remain on a machine using preliminary laboratory analysis values. And although the MLR is not the most suitable model, we will consider the basis to find this optimal interval only to exemplify. So, first step is represent the total number of anomalous diagnoses in the classification. So we define as by a single threshold value concerning the total number of hours at service of a given load. We can have anomalous diagnosis above upper control limit, which are normal, and below control limit, which are watch or risk. And if we consider the two limits equal, we can see that we find a threshold of 932 hours for a total of 29 misclassification diagnoses. But this value is a natural choice, but it's important to give the customer some room for maneuver. So we consider a 95% confidence interval, and we calculate the limits, but it's necessary to have the vector of the values of the explanatory variables. So we use a Python algorithm to check all possibilities, combination of integer values of the explanatory variables, and return the one whose value is closer to the 32 hours, and is the values for this case of the variables as these ones. And we can find this interval here. I'm finishing this interval, and using this interval we can see we can see not very well, but there are two normal diagnoses above the upper limit, which is this one, and we have more 11 about the yellow ones, and the red ones we don't see very well here, but there are 11. Two watch diagnoses and 9 watch and 2 risk diagnoses. In the next step, we allow to shift this interval in order to search with the same amplitude, but to search the one that minimize the number of anomalous diagnoses. And we have one, if we add 59 hours to our interval, we evolve one extra misclassification, and we get the optimal interval in this case, which is represented here. And the last step consists in reusing the algorithm to find the predictors that the integer values for the new center of the interval. So, thank you. I finished. Thank you for your attention.
Thank you, Sada. So, to proceed in time, someone have remarks in the coffee break, tea break, we make some observations. I proceed with Francisca. Francisca. Partly this is Francisca. Sorry. Sorry about that.
Scusa. Stava qui, c'è anche il contatore? Ok. Good morning. I'm Francesca Pierri, and this is a joint paper with Damiano Perri and Professor Chris Caroni, coming from the University of Athens. The title is Beyond the Cox Model, Applying Machine Learning Techniques with Time-to-Event Data. The outline of the presentation is the following: a brief introduction to explain the aim of this work, a brief recall to survival analysis, that is the methodology used in this paper. And so I will remind something about the Cox proportional Hassel model and penalized regression approaches based on the Cox model. Then there is an application, so there is a data description and results. During the last period, longitudinal data analysis are enhanced. The interest to study of the study in medicine, in engineering, and economics. And the aim is to predict the time of the occurrence of an event and to collect data for this kind of research. You must fix a start and the end of the observational period, and you have to collect information about the subjects. And during this period, you will observe an event only for some subjects. So you are in presence of sensory data. And you cannot apply apply predictive algorithms using standard statistical or machine learning approaches. So during the years, the Cox model have been largely used in survival analysis to handle sensory data. Nowadays, machine learning techniques have become increasingly popular, and comparison among the classical and the new models may be of interest. The purpose of the talk is to expand previous researches in the field of corporate default risk prediction and apply machine learning methodologies developed for survival analysis and compare results with classical survival model. We have used two different software. Shikit Survival is a Python module for survival analysis designed to be compatible with Scikit-learn API, and this is evaluated as a machine learning technique. And then we use the SAS PHREG procedure to apply classical survival analysis techniques. Python, as you know, is an open source software. SAS is a commercial software, but it's free for students and teachers. So it's widely used. A brief recall to survival analysis. Survival analysis designed to connect covariates with the time of an event. In clinical research, the primary goal is to predict the time of death, which is survival. In engineering, it is known as reliability analysis. In economics and finance, it is used in the credit scoring field to understand the causes of financial distress and identify the main predictors of the probability of business failure within a given time frame. The survival functions is a key measure that relates time to the probability of survival past a certain time period. T denotes a continuous non-negative random variable, and the survival function returns the probability of survival beyond time t. The initial value at t equals 0 is obviously 1. The ft is the cumulative distribution function that represents the probability that the event of interest occurs before t, and the other function represents the rate of event at time t, given that no event occurred before time t. The Cox semi-parametric regression model defines the dependence of the hazard function on the values of a vector covariate x, and the effect of the covariates,
the middle.
Okay.
Yes.
The effect of covariate x is expressed by beta, the exponential of beta, and an increase of 1 unit in the value of x leads to the multiplication of the hazard by the amount y the survival function is raised to a power. And the coefficient beta show the effect of each covariate on both the rate and risk of failure. The estimation of beta is effected through the partial likelihood method, and there is no specification about the baseline is required. When you estimate beta, you can meet two different problems: correlation among variables and high dimensional. And you can meet problem with high dimensional data. High dimensional, the problem of the inversion of the matrix can be solved using penalized method like lasso, ridge, or elastic net methods. And the lasso method, called also L1 penalty, is given from this in this formula. L beta is the log partial likelihood function of the Cox model. Beta are the key parameters for the key features, and alpha greater or equal 0 is a hyperparameter that controls the amount of the shrinkage. When alpha is equal to 0, you have the Cox model, the classical Cox model. These are the penalty of the L2 penalty or ridge penalty and the elastic net penalty, that is a mix among the lasso and the ridge penalty. Oops.
This is real life in the point.
Okay. Perhaps it's my. Okay, sorry, I'm losing time. Okay. So data used are collected from Orbis database, and we consider Italian firms operating in the manufacturing sectors. And we know financial data for the last available year in the period of 2000-2018. We know the legal form, the legal status, and the geographical location of this firm. Here there is a description of the active and bankruptcy firms, and you see that the data are unbalanced, fortunately. So the research choices is the following. A data balancing operation, randomly choosing a number of active firms equal to the one closed due to bankruptcy. And so we had some reduction of the sample size. Then we split the data in training sample and no-doubt sample. And then we built financial indexes representative of the firm's overall performance status, like profitability, efficiency, solvency, and liquidity. And then we perform a regression analysis on survival data based on classic Cox proportional hazard model using SAS PHREG and penalized method using shifted survival. Then we compared the two kinds of analysis. Okay. This is a short description of the data. You see that on the south and on the center, we have the south and in the insular, we have the highest percentage of bankruptcy. Is the column percentage, and why is doing in this way? Can we do in a different? Can you split one another? Thank you, Damiano. Otherwise, I'm going to lose. I'm not touching anything. It's moving by.
I moved the slide for you.
Okay. Behind.
Stop.
Go on.
No. Before. No, after that. After the tables.
Dopo.
This one. I see this one.
Okay, this is the geographical area, the difference among the geographical areas, so we can see the next one. And then we have the distribution of firms on the basis of the legal firm, and we see that we have a higher percentage in private or bankruptcy in private limited company. And classical survival was performed with SAS-PH-REG. And first of all, I solved correlation problems among the indexes, and among indexes with correlation higher than 70%, I included only one of the index on the basis of the broader applicability, the lack of correlation with other indexes. And then I performed a stepwise model selection method to obtain the best model, and I obtained among the significant variables legal form, geographical area, and 17 indexes, and the predictive ability tested on the validation set is 0.78, and the area under the curve varies obviously from 2 to 10 years, and it is higher when you have 10 years, so it reaches 0.80%. This is a quick view of the results. You may see the estimated coefficient, the hazard ratio, and the confidence interval. When the hazard ratio is higher than one, the meaning is that variables affect positively the bankruptcy. When the coefficient, when the hazard ratio is less than 1, it is protective. It is protective. So it less with the firm goes to bankruptcy with less probability. And you can see the same on the estimated coefficient. If the coefficient is negative, it is a coefficient protective. Otherwise, it increases the bankruptcy. When you consider the categorical variable, you have a reference category. So you have to consider which is the reference category. So, for instance, the South does an hazard ratio 1.286, goes to bankruptcy more frequently or with a higher probability than the Central. These are the other variables, and I underline the importance of the index 0.82. It has an high estimated coefficient 5.28. It is a value that we can find in the next slides, and in 0.29. They are indexes of indebtedness of the firm. For penalized method, I just say you that we use the scikit-learn, and for lasso, we use Coxnet survival analysis library, and the alpha value selection is the following. At first, a value that does not take into account any features, and then a decreasing value until it was only about 1% of the initial value. And the final L1 value is not returned by the software, and we have seen that larger alpha values selects a smaller subset of features, and the best alpha value gives back a concordant index in the validation set equal to 0.79. In the next slide, we can see how in this software the most important features are identified. Here are the feature protective, and these are the features that increase bankruptcy. And you see in 0.82 is the same that has a high coefficients in the classical regression model. And for region, we use Cox-PH survival analysis library. Alpha values, we evaluated the various alpha value. 0.5 is the minimal viable value determinant, and any lower value cause a system crash. And the concordant index for alpha equal to 0.5 is 0.7943, and for alpha equal to 8 is 0.7955 volts. They are very close. Again, this is the graph shown by Python, and we see again in 082 and in 042 as the opposite direction against bankruptcy. And for elastic net, we use it as initial barrier for L1 0.9 and alpha mean ratio 0.01. The last value chosen for the penalty parameters are not shown. And the concordant index in the validation set for the top performing model is 0.7943. And the most significant features differ from the previous two penalized method. There is always 0.82, but we have different values here. Reach shows the best concordant index in the validation set. The difference among the penalized method lies in the third decimal place. The difference from classical survival lies in the second decimal place. And lasso and ridge methods select the same 5 significant features. Elastic net incorporates only a subset of the features chosen by lasso and ridge, and classical survival selects more features, 17, and among these emphasize the significance of legal form and geographical area that is quite important in the analysis. As conclusion, the classical model offers more detail and may be easier to interpret. The output clearly presents the coefficient values, the hazard ratio, and confidence interval, yet it has in this case a marginally lower concordance index. Penalized methods appear to be more concise and provide an immediate insight into the most significant variables. There are no significant differences in predictive ability between the models. The selection of one method over another should not be predetermined, but should always be based on a comparative analysis. Questions?
Thank you. I pass to audience some questions. No? Only one remark. You use all the embedded methods, the lasso, comparing some libraries in Python with SAS. The SAS, for example, for Portuguese students are not free. You are free licenses in.
There is if you have SAS study, you download SAS study. And
they have the same functionalities?
Yes, exactly the same. The difference is that you are not allowed to use data, commercial data. So it's just for researchers. There are some slight differences. For instance, you in some procedure, very particular procedure, you cannot use the graphics on. It's the best performance for graphs, but you have all.
Yes.
You have all, and I've run a big amount of data, so you can register by yourself. You say you are working in a research group, and so on. It is free.
We have a lot of free licenses.
And it is there is an app online, and so it is more friendly than the previous SAS. It's very easy to use.
Yeah. It's a Windows user. And thank you, Francesca, for your participation. we go finish this session of the computational applied statistics. I raise the thanks to all of the audience, and I want a picture with all the intervenients, with the help assistants, Simon, and all speakers. Only three. Humberto, please. This is my photograph of service. Simon, stay here, please. I go to my address. No, Francisca, Daniel, join to us.
Okay.
Join to us.
Cheese.
Cheese.
Several cheeses.
How many cheese?
Dishes.
Ai, quantas difíceis é esta hora do dia?
Vamos chatear.
Damiano, you know something about certificates?
Certificates. We are working.
I tell her the difficult questions at this time of the day.
We need the certification for the reimbursement.
We will send to all the people.
Vai,
Well, via the official website. Via the official website.
The
Yes.
website, in the
website.
submissions website, you can download.
Ok, thank you.
Devias ter uma coisa destas.
Diga.
So, this is like in the marriage, the photos. Photos
Two pictures, because I have
Two different presentations.
Yes, I work in the bank groups, it will be the PhD student at this time, but in the different levels of bank groups. We try to define things, so that's different levels, and with some figures and macroeconomic activities. And this is
Okay, thank you.
Yes.
Vicky?
I have another paper about this one, and we have selected
yeah, there are
movements, and when you, so you go on confidation, and when you are close for
Sorry,
yes.
yes.
But in this case, we have started just
Because I have
the binary, yes.
Yes.
Works. I contact you.
I work on credit scoring field, so
Yeah.
I.
Okay. Thank you so much.
Thank you. Models, all the models that to the model. And at this time,
Romeo?
I would like to try to use machine learning, so Giuliano had me find them. And
I know.
I had the idea, and that idea is to use, there was a meeting here in London to, for the 50 years of the dogs.
Yes.
And someone said about the user, but now they are not implementing, so I'm asking Damiano to work on it. But it could be a different approach. I don't know really if when you give results coming from machine learning to framework to that, if they can understand the meaning. Because you put all in a, it's quite difficult for me because they put all in a blank box and then you are directing the result. If you don't know what this one is.
It's this because
And
it's
this was the problem to the research. And I couldn't say, okay, I've done. What have you done? No.
I'm statistician too. I'm trying to explain.
Have you balanced the data? No, you do it by himself. How? So I say, which is the number of the solution and they put the data inside of the results and then
Statistically measures, in the case of the delirium, we have this problem because of the unbalanced data. I prefer to work with the real data because I understand what happens. When I create the statistic measures, I don't know. It is the same, I select the same individual to put in my analysis. I don't know what happens with the.
if you have a test, there is an official test. On the basis of some measures, you put the results. If you have the value of the questions, I think it's better because when I did this thing about this I tried to use the final result, but then I tried to see if the final response was
Consistent with
Yes.
the reality.
Yes.
And sometimes it doesn't work.
It's quite difficult to work
Yes, it's difficult.
Yeah.
And
It was very difficult to work. Anyway,
it is a challenge to, every day is a challenge to work with.
so, do you come from Portugal?